In this video, we'll be dealing with problems involving vertical projectile motion. Let's begin. Stone A is thrown vertically upward with a speed of 10 meters per second from the edge of the roof of a 40-meter high building, as shown in the diagram below. Ignore the effects of air friction, take the ground as reference. First question, define the term free fall. A free fall is the motion in which the only force acting is gravity. Second question, calculate the maximum height above the ground reached by stone A. Well, for this question, we need to choose a positive direction. And in this case, I'm going to choose up as positive. And also important detail to remember is that we asked for the maximum height reached by stone A. And at the maximum height, velocity is 0. So we have our initial velocity, which was given in the question statement of 10 meters per second. We know our final velocity is 0, and we're asked to calculate the change in displacement. So we'll be using this equation of motion. Our final velocity is 0. Our initial velocity is positive 10 meters per second because we've chosen up as the positive direction, and A is being thrown vertically upward. Our acceleration due to gravity is 9,8 meters per second, and it's a negative 9,8 because gravity always acts in the downward direction. However, we've chosen up to be our positive direction because it's acting in the opposite direction of our chosen direction convention. Then our acceleration is going to be negative, and delta y is what we're looking for. Simplifying and solving, we are going to find that delta y equals 5.1 meters. And this 5.1 meters is the height that stone A reaches after it's been projected from the top of the building. So when stone A reaches its maximum height, the distance from this maximum height and the top of the building is 5.1 meters. So to get the maximum height above the ground reached by stone A, we have to add the 40 meters, which is the height of the building. Third question. Write down the magnitude and direction of the acceleration of stone A at this maximum height. Well, the acceleration is due to gravity because stone A is a projectile, or it is in free fall. So the only force acting on it is gravity, and thus the acceleration is due to gravity. The acceleration due to gravity is 9,8 meters per second squared. And gravity always acts in the downward direction. Final question. Stone B is dropped from rest from the edge of the roof X seconds after stone A was thrown upwards. Stone A passes stone B when the two stones are 29.74 meters above the ground. Calculate the value of X. So for this example, I'm going to draw diagrams for stones A and B. Start with stone A. So we're told to take the ground as reference, and 40 meters above the ground is the top of the building, and this is where stone A was projected from. A's initial velocity, so the velocity with which stone A was thrown up, is 10 meters per second, and this is given to us in the problem statement. And this is at time t equals 0, right? And then at 29.74 meters above the ground, this is the point where stone A meets stone B. And this is at time t equals t. Calling it t equals t because it's a variable which we have to calculate. Similarly, for stone B, we're told that stone B is dropped from rest from the edge of the roof, so its initial velocity will be 0. And this is at time t equals x seconds. This is the x seconds after stone A was thrown upwards. And at 29.74 meters above the ground, stone B meets stone A at t equals t seconds. So they meet each other at the exact same time. We are going to use this equation of motion. Delta y equals vi delta t plus a half a delta t squared. And just a side note, delta, these triangles, symbol delta, means change in. And typically this is the final value minus the initial. Okay, well, now solving, we'll start with stone A. And substituting into this equation of motion, delta y is our final 29.27, 29.74, I beg your pardon, minus our initial, which is 40. We are not concerned with the maximum height that A reaches above the ground, because if we look at the path that stone A takes, goes up like this and then comes down, this section here, delta y here, is essentially 0, right? So we're only concerned about this point here, from when A is coming down from its maximum height and crosses this 40-meter height of the building and comes to meet stone B at 29.74. This is the delta y that we are concerned about. Going back, delta y 29.74 minus 40 is equal to, our initial velocity for A is 10, positive 10, because it's thrown upwards. Delta t, remember we said delta means change in, final minus initial. Final time was t equals t, minus the initial, which is 0, plus a half a being our acceleration due to gravity, gravity acting downwards, and we chose up as positive, so it would be minus 9.8 meters per second squared. Delta t again, t minus 0 squared. Simplifying, here we're going to get 10.26, negative 10.26 is equals to 10t, right? T minus 0 is just t, minus 4.9 t squared. Rearranging this formula, I've got 0 equals negative 4.9 t squared plus 10t plus 10.26. This is a quadratic equation, and we're going to use our quadratic formula to solve for t. Our quadratic formula is this. T is equals to negative b plus square root of b squared minus 4ac all over 2a, or t is equals to negative b minus, you see the difference? What was a plus, now it's a minus, square root of b squared minus 4ac. This was learned in grade 11. The quadratic formula was learned in grade 11 math. Our b is the coefficient of t, our a is the coefficient of t squared, and our c is our constant here, 10.26. Substituting and solving, we get minus plugging this into your calculator, you should get t equals to 2.79, or t is equal to negative 0.75. We can't have a negative for time because time is a scalar quantity and not a vector quantity. So this is not applicable. So in essence, it takes stone A 10 seconds, right, from when it was projected upwards to reach this point here at 29.74 meters above the ground where it will meet stone B. So now to solve for x, right, which is the number of seconds after stone A that stone B is now dropped, we do a similar thing for stone B. Right, using the exact same equation of motion, change in displacement of stone B is going to be 29.74 minus 40 is equal to, well, B's initial velocity is 0 because it was dropped from rest. The change in time is t minus x. Gravity is negative 9,8 because we chose an up as positive, and gravity always acts in the downward direction. And our change in time again is t minus x squared. Simplifying, we get negative 10.26 is equal to this, it's just 0. Anything multiplied by 0 will just give us 0. Negative 4.9 t minus x squared. Our t value is 2.79. We calculated this previously. So simplifying again, we'll get negative 4.9, 2.79 minus x squared. That is equal to negative 10.26. Doing some algebra, so we're going to expand this bracket. right? Because it's the whole entire bracket squared, so it's basically the bracket multiplied by itself, and then we are going to FOIL. Now we're just multiplying by this negative 4.9 to all the terms in this bracket. This is equal to 10.26, negative 10.26. So this is negative 4.9x squared. Rearranging, and then negative 38.12 plus 10.26 will give us 27.86, negative 27.86. And this is a quadratic equation. It's very similar to what we did for stone A. We are now going to solve for x. We get an answer of x is equals to 1.34. If this was a minus, so negative 11.34 minus square root of 27.34 squared minus 4 times negative 4.9 times negative 27.86, all square rooted, all over 2 times negative 4.9. Here we get x equals 4.23. Know that this is not applicable because it takes a 2.79 seconds to reach this point here where both A and B meet, and so it can't take B longer than this 2.79 seconds. Can't take B longer than this 2.79 seconds. Otherwise, stone A would already have moved past this 29.74 meters. So conclusively, x is 1.34 seconds.